I don't know if anyone wants to put the questions. If not, over there.
Thanks for your nice presentation.
Sorry. If you don't mind, I will ask to present yourself and where you come from.
Okay, thank you. This is Ghaffar Hussain from VT on Textile Research. We are also engaged with different line in smart textile research. And we also, of course, work with the sports or for sensing different body activities. And the things what we challenge, we feel the challenges for today or tomorrow, the washability, how you can think that it can be improved, because in each sports activity you need washing. So just for to know how you think that it can be overcome for tomorrow's challenge. Thank you.
Thank you. Susan.
I don't think there's a general solution. Again, I mentioned it also as a challenge, possibility in relation to the liability. I think that's also possibly typically see that more conventional wearables, like smartwatches, have simply a larger market share than textiles. In biology, we typically study the adhesion of the printed sensors, of the printed interconnections of the textile with the deposited material, and we study different pre-treatments. And I'm not saying that we make good progress, but it really depends on the type of polymers that we deposit, the type of inks, and they all require different solutions.
Yeah. Thank you. Anyone? More? Two more questions over there first, and
okay. Hello. Good morning. Thank you to all of you for the interesting talks. This question is, I'm Paula Felix from Leitat. And my first question is for Dr. Yassim. Hello. Well, thank you for the talk, and I'm curious about if you work with PCMs for medical textiles.
Sorry.
Yes.
Can you repeat it, please?
Yes. Have you worked with PCMs in textiles?
I have never worked.
Okay, because I was curious about it. I saw it on one of the research lines.
Yes.
And I was curious about your experience on.
No, I didn't
them.
work personally, but I know that we are using it in medical, but also in the sports with thermoregulation clothes.
Yes.
Which is adapting the temperature of the body for the weather, but not directly.
Okay, okay. Because, the thing is that most people claim that after a period of time, PCMs stop working. So that was I just wanted to know about your experience with the PCMs. Thank you. Anyway, and I have another question for Dr. Enrico. You said that you got a patent in photocatalytic materials, and I'm curious about the applications. What applications are you thinking of for this type of materials?
The photocatalytic function can have many different applications. The application of these nanoparticles on textile have to be still explored and refined, but there are other materials that are very well compatible with the application of nanoparticles, like PVC panels, for instance, or other more rigid material. There are some fibers that are better compatible with the application of nanoparticles, these particular nanoparticles, because of course there are many different kind of nanoparticles. I had a graph that I didn't have the time to show, but depending on the chemical nanoparticle, of course, the degradation properties are different. So the titanium dioxide is, as far as we know, the most effective, and our patent is about titanium dioxide, and it is very effective. But as it is also very aggressive, it has to be very well balanced with the textile, and also it has to be adapted to the nature of fibers. Of course, natural fibers are more sensitive, and so they can create problems when you go when you treat the natural fibers with these nanoparticles.
Okay. Okay.
But
thank
for
you.
sure, it is a very nice, interesting, and promising field of application.
Yes. Have you thought about using this type of materials in the automotive sector?
Yes.
Okay.
Yes.
Yeah.
Yes, but again, you can use on different substrates
Yeah.
for the automotive sector. And yes, there are many R&D activities going on in this respect in order to make the interior of a car more comfortable and also more hygienic, because you can reduce the amount of bacteria and pollutants that are present into the interior of the vehicle.
Okay. Thank you.
Well,
Okay, thank you. The last question, because we need to unfortunately, we haven't time to stay here all the morning.
Thank you very much. Thank you all of you for very interesting presentation. I'm Constance Moretti. I come from a French company which is producing luminous fabrics based on optical fibers, but I will present a little bit more this afternoon. And my question is for all of you. Actually, you all are experts in smart textiles in your domain of applications, and all of you have a few years of expertise. And what I saw today is that the conclusion today is the same as the one it was a few years ago, meaning that smart textiles has many potential and can do great things, but is still not mature. So my question is, are you optimistic about the future of smart textiles for concrete applications?
I don't know who wants to.
I was the last one, so perhaps I can take the lead then. Well, I agree with that. I think that's also partially my conclusions. That still there's a lot of expectations. Yeah. I honestly believe that there is large potential, else I would not be active in the science domain. I think that would be highly demotivating if you don't believe in your own research. But I also believe that I think it depends on the domains in which we focus. And I think when it comes to sports and people speak about heart rate sensors and breathing monitoring and GPS tracking systems, in the domain of sports, it's very, very challenging to compete there with the existing technology. And maybe maybe people focus too much on that. I think textiles have much more potential than only trying to compete with the existing heart rate sensors and step counters and so on. I think that is basically where I think we should change a little bit our attitude. And I think that was also one of the topics yesterday of the work group 5 meeting. Like there is much more than only these domains where there's large competition anyway.
Thank you, Vicente. Just to finish.
Yeah, perhaps I can add something. Of course, we are optimistic on the use of smart textiles. Otherwise, our work was not good on what we are doing. But I agree with you. There are lots of barriers, still barriers to, not from the technological and scientific point of view. I believe from that side we developed lots of new achievements over the last 10 years. But the problem is on passing these technologies to the market, because the issues there are completely different. And as the other colleague said, the part of the washability, the maintenance, the reproducibility of the system, the reliability of the systems we are developing. So we need to do a lot still on those areas to place these technologies into real solutions, and perhaps in mass-scale solutions, because otherwise these materials cannot compete with the existing materials in different domains. I believe we have more possibilities, again, when we combine these smart textiles with other materials. And for those applications, I believe we have huge opportunities for that, because when we encapsulate these smart textiles with polymers or with metallic materials or with ceramic materials, we can always protect the smart system with other material. And for those applications, aeronautics, automotive, sport goods, but in terms not in clothing, but perhaps in sport equipment and so on, I believe the solutions will come to the market more quickly. Yes, that's why that example of Nike, I guess, on the shoe, all the smart system perhaps is encapsulated in the polymeric material.
It's more wearable.
Yes.
by that.
Yes.
And I think that is basically my
the
message.
point.
We still should make the transition from wearable to truly embedded.
Yeah.
And that is, I think, also what you referred to.
Okay, thank you, Raul. Thank you to all of you for your presentations. Just to finish and to keep us or bring us for the scheduler of the agenda, we have a coffee break on the room behind you. Let's try to be here in 15 minutes. Okay?
Yeah, just as a reminder, the coffee break, it's going to be